Welcome back, everybody. It's been a little while. Tonight we're talking about direct variation and the constant of proportionality. This really goes along with Chapter 1, Section 9, I believe, if you need to refer to there later. All right, filling in these few blanks at the beginning. When two variable quantities have a constant ratio, their relationship is called a proportional relationship, what we've been talking about for a while. Proportional relationship. So we've been identifying proportional and non-proportional relationships. Some of this will be review, and some will be new. The number that is the constant ratio, no units, is called the, we've seen this word before, constant of proportionality. Constant of proportionality, also called, it's the same as the constant of variation, but I've been calling it the constant of proportionality in class. So just to make it even more confusing with more vocab. Let's see what we're going to do with these tables and graphs. We're going to go get some frozen yogurt. Kyla ordered a frozen yogurt. The cost was 50 cents an ounce. Record the price in the table and graph the results. All right, so if she buys 1 ounce, 50 cents. 2 ounces, double it, $1. 3 ounces, $1.50. Keep adding 50 cents. $2, $2.50, $3. All right, now graphing this. So a reminder that whenever we have a table, our x value is the first one and our y value is the second. So I need to label on my x-axis ounces and cost in dollars. On the y-axis, pay no attention to that dot there. All right, so let's count things out and make sure everything will fit before we label. I have to go up to 6 ounces, and I just know there happens to be 12 boxes on the x-axis and the y-axis, so I'm going to count by every 2 boxes is 1 ounce. Making sure I have even and equal increments all the way across. Every 2 boxes is 1 ounce. And for my cost, I have to go up to $3. Actually, I think there's only 11 boxes that go up. So I'm going to add an extra box. I'm going to say that every 2 boxes is 50 cents. Remember that as you're watching this, if I'm going too fast, feel free to pause and slow it down, rewatch. I'm going to add 1 box here to my y-axis to go up to $3. Okay, so plotting points. This is just like the coordinate 1, 50 cents. A reminder that when you graph, you walk into the elevator before you go up or down. So starting at the origin, I walk over to 1 and then up 50 cents. And 2 ounces was $1. 3 ounces is $1.50. And I'm making a nice straight line that goes up. Draw that line, connect the dots. Okay, now we're going to be analyzing this a little bit more. In the box here, compare the rates of each part of the table here. All right, let's start with the easy one. 1 ounce is 50 cents. A reminder again, we're always doing y divided by x every single time we find a unit rate. So I can start with 50 cents per 1 ounce, and that already is a unit rate because it has a denominator of 1. Do the next one, $1 per 2 ounces, and we are always dividing. This is easy to do mentally. This is also 50 cents per ounce. Let's try one more. How about $3 per 6 ounce, or you could choose your own. Again, it's always 50 cents per ounce, right? So I think you see where this is leading. Let's go on to the next example. Dylan goes to a different frozen yogurt shop. This one has $1 that you have to pay for the fancy cup, plus 25 cents per ounce of yogurt. Graph the results. So if he buys 1 ounce, we have $1 plus the 25 cents per ounce for a total of $1.25. For 2 ounces, he pays that ridiculous fee of $1 per ounce, $1 per cup, plus now 50 cents for 2 ounces, so $1.50. And I think you can see that each time we add an ounce, we're going to be increasing the price by 25 cents. 175 to 225 up to 250. Take a moment. You might want to pause the video. I'm going to pause the video while I label my graph the same way as the other one. You do the same. Once your graph is labeled, go ahead and plot those points. 1 ounce is $1.25. So again, having done this the same as the previous graph, every box represents 25 cents. 2 ounces is $1.50. I'm going to keep adding on 25 cents. And draw that line. Feel free to draw the line all the way to the y-axis, even though we don't have a point there. However, it's important to notice that if Dylan went to the store and just wanted to buy this fancy cup for $1, well, buying 0 ounces right here would still cost him $1, because he's paying $1 for the cup. Going to the box, let's compare the rates. So I'll start with the easy one. $1.25 for 1 ounce. That already is a unit rate. If you have the choice of comparing these, pick the ones where the numbers seem easier to divide. I'll pick $1.50 for 2 ounces. That reduces to 75 cents per ounce. Uh-oh, not the same. And I'll do one more, $2 for 4 ounces. Because it's easy to divide mentally, 50 cents per ounce. So I realize these all have different unit rates. Let's go on to the back to discuss this some more. Okay, so we should know right away whose rates were constant. Remember that word from our notes, meaning the same for all ordered pairs. That was Kyla's. Every single time, 50 cents per ounce, no matter what. Whose graph shows a proportional relationship? From what we've already learned, which one goes through the origin and is linear, a straight line? Kyla's again. So if her unit rates are proportionate, the graph is also always proportionate. Explain why. For those two reasons. It goes through the origin and it's linear. Now, moving on to the new part. That's all review. Write an equation that compares the cost of yogurt to the number of ounces for both graphs. So this is where we're bringing in direct variation. How do we write an equation for a proportionate and a not proportionate data? So direct variation uses this formula, y equals kx. We had that in our notes before. The k stands for the constant of proportionality. Actually, that's written down below here. K is the constant of proportionality. Direct variation is always in this format, the simplest form of an equation. So, what is that constant of proportionality? Well, what was the same for Kyla? Basically, we're looking at what was her unit rate. The unit rate was the same the whole time. Her constant of proportionality was 50 cents, 0.5. Let's take a look at this graph for a moment, because we're going to be talking about something also called the rate of change or the slope. If I start at the origin, every time I go up, remember how we're always dividing y over x? If I go up the y-axis and over the x, every time I'm going up 50 cents and over 1 ounce. If I go up to the next point, I go up 50 cents to $1 and over 1 more ounce. And it's always the same. Add another 50 cents to 150 and add another 1 ounce to make it 3 ounces. So her constant of proportionality is 0.5, our unit rate. Here's how we write the equation. Y equals 0.5x. We simply replace the k with a number. Now, adding on to this tells us to write the equation using these other variables. Which is the cost of the yogurt and which is the number of ounces? Well, I know that every time I'm buying an ounce of yogurt, I'm multiplying it by 50 cents to get my total cost. So the y is my cost, and the x represents the number of ounces, which I'll use for n, just because I was told those variables to use. So that's how we would write that. This is direct variation. Now, Dylan's, does his show direct variation? Was his proportionate? No, it wasn't. The data's not. We have different unit rates every time, and his graph does not go through the origin. It's linear, but doesn't go through the origin. So his cannot be written in direct variation. This is something we'll work more on later on how to write these equations, but I'll give you a heads up right now. Let's look back here. So just like I did for Kyla, if I start here at the y-axis, if I go up to this point, I would be going up 25 cents in this case, and going over 1 ounce. When I go up again to the next point, I'd be going up 25 cents and over 1 ounce. This is really how we find slope, or the rate of change. 25 cents per 1 becomes just 25 cents, 25 cents over 1. I'm going to start his equation the same way. Y equals, now this is not a constant of proportionality. Even though there's a number there, it's not a K. You can't call it that if it's not proportionate. Now, Dylan's wasn't only 25 cents per ounce because you had to pay that dollar charge for the empty cup. So I have to add on $1 here. Notice that Kyla started at 0. She didn't have to pay for the cup. So if I did add plus 0 here, it doesn't mean anything. I wouldn't write plus 0, but I could. For Dylan's, we have to write plus 1. Now, just to replace these variables, y again is also our total cost. And we're saying he paid 25 cents per ounce, per number of ounces, plus the $1 cup. Don't be so concerned about how to write this equation. That's not what we're really focusing on. But we will learn more about that later. To review some vocab. The equation for Kyla's graph shows direct variation. The relationship between the cost and the number of ounces varies directly. The constant of proportionality, or another vocab word, constant of variation, just to make it confusing, for Kyla is 0.5, meaning that she paid 50 cents per 1 ounce of frozen yogurt. Writing this another way, this is the same number that is the rate without units. Well, a rate technically has units. This would be 50 cents per 1 ounce. Or as a ratio without units would be just 0.5. Or I could put that over 1 if I want to, but that's unnecessary. For review, when you come into class, I have 5 questions prepared for you right now. You will need to write this down somewhat, these 5 questions, on your paper in the space and answer them. Notice they're all multiple choice. You don't have to write everything, but you should remind yourself what is this question, and then write your choice of answer. You may need to review back to the notes that we've already written if you're not sure of the answer, from notes from the previous day. So which of these is in direct variation, A or B? What is the constant of proportionality for this equation? What is the constant of proportionality for this equation? Number 4, for a graph to be proportional, what must be true? And number 5, true or false? Non-proportional graphs can't be linear. Thanks for watching. See you next class.